Hi everyone, and welcome back to my channel. Now I have to apologize yet again for taking so long to post a new video, but as I mentioned in my last video, I've been spending a lot of time behind the scenes working on my CNC technique. In particular, I built a couple of clamping jigs, one of which I showed you in the last video, I believe. So I got the body out and a neck, just to refresh your memory visually on what I'm going for here with this project. In today's video, I'm going to be showing you the process for carving a neck shaft from start to finish. Now, some of this you've probably seen before in other of my videos, but I don't believe I've ever done the complete process from start to finish. When I say start to finish, starting with dimensioning the lumber, gluing it up into a blank, and then carving it on the CNC machine. That's what we're going to watch today. So as usual, I'll just sort of talk you through the process. Then we'll come back on the flip side and I will discuss my next steps. So the first thing I need to do is dimension the lumber for this neck blank, which I'll be doing mainly on the bandsaw and the planer. Here I've got a piece of Purple Heart that I'll be using for the neck stringer. So the first step is to rip it in half to make it the correct height, after which I'll flip each piece on its side and do what they call a resaw to cut it in half along its length. As you can see, I'm pretty careful about keeping my hands well away from the blade and using a push block. Now, once I'm done resawing the Purple Heart, my next step will be to resaw a piece of hard maple, which I'm going to use for the center stringer. After that, it's time to move over to the planer. Now the planing process is pretty straightforward. Basically, I've secured the lumber to a sled using double-sided tape, and now I'm running that sled through the planer. The goal here is to get each piece to a final thickness of about 9 millimeters, so I'll check my progress as I go along using calipers. Now that I've got all the lumber dimensioned, it's time to glue it up into a blank. And to do that, I'll be using the 4-way clamps that you see here. My technique is pretty simple. Rather than using a glue brush, I just put on a nitrile glove and spread the glue with my fingers. The goal here is to get uniform coverage on each face, edge to edge, and as usual, I'm doing the pieces in sequence. Once I've got all the pieces in place, it's time to add the upper portion of the clamps as well as some spacers at each end. I'm using the spacers because the outer pieces of maple are the exact same dimension, unlike the stringers, so the spacers guarantee that the outer rings are level with one another. Once the 4-way clamps are tightened, I basically need to apply every remaining clamp in my garage to ensure a seamless neck blank. Once I've cleaned up the blank and run it through the planer to get it to the correct thickness, I'm ready to start carving on my CNC machine. The first step is going to be mounting the neck blank to my new clamping jig, which I unveiled in my last video. Now the challenge here is to make sure the blank is perfectly aligned along the machine's x-axis, which runs from left to right. So what I'm doing now is just eyeballing the blank and adjusting the clamps in preparation for the next step. That next step is to use the machine itself as a reference to make sure that the blank is properly centered. It doesn't have to be exact, but I want to get it as close as possible. Now, it occurred to me recently that I haven't really shown my CNC computer setup in one of my videos, so here it is. It's pretty simple. The whole thing is mounted to a stand-up computer cart that has casters. The CPU is one of those mini PCs, and that's mounted to the back of the monitor. And of course, there's a shelf for the keyboard and mouse. The main advantage of this setup is that it's movable and easy to wheel around, which you'll see in this scene. So what I'm doing here is using what they call a touch plate to run a probing sequence to get my zero coordinates for the X, Y, and Z axes. All of the carving operations I'm about to show you start from the southwest corner of the blank, so it's crucial to have accurate coordinates. This is especially true for operations that involve a rough carve followed by a finish carve, which you're going to see shortly. So the first carving operation is to cut the slots for the truss rod and the carbon fiber reinforcement rods, which is a fairly simple operation. In these clips, I'll try to start at actual speed before increasing it, just so you can see how fast the machine actually moves. Now that the slots are carved, I need to carve the headstock paddle, which is what you're seeing here. This is one of those operations that involves a rough carve to hog out most of the wood, followed by a finish carve to get the piece to its final dimension, and more importantly, to smooth out the stair-step effect left behind by the rough carve, which you'll see in a moment. Once the rough carve is complete, I'm going to run the finish carve, again, starting from the exact same machine coordinates that I used for the rough carve. You can see here that I'm using a carving program that runs parallel to the x-axis or left to right, because in this case I want the carve in the direction of the grain rather than against it, which will improve the final finish. Now that I've finished all the carving operations for the top of the neck, it's time to prepare for the back carve, which is a lot more complicated and time consuming. To do that, I need to install threaded inserts into the holes I've carved in the truss rod slot. These are the inserts I'll be using to screw the blank to the jig, as I discussed in my last video. Just as a reminder, what I'm going for here is a clamping strategy that holds the blank in two places. From the bottom using the threaded inserts and some screws, and from the side using the clamps. The screws and the threaded inserts will immobilize the final product from below once it's liberated from the overall blank, and the side clamps will prevent the remainder of the blank from moving. As I mentioned in my last video, the goal here is to minimize the use of tabs for securing the final product of the rest of the blank. Tabs work okay, but they're tough to clean up, especially on curved surfaces. Once the threaded inserts are installed, I'm ready to secure the blank to the jig. To do that, I'll flip the jig and screw the blank in place from the back. You can see that the back of the jig has recessed slots for installing the screws, which gives me some adjustability and margin in terms of aligning the screws with the threaded inserts. Once the blank is screwed to the jig, I can flip it again and mount the whole assembly to the CNC table. To do that, I'll secure the jig to the table, also using a combination of screws and threaded inserts, and then I'll install the side clamps. After that, I'll run through the same process of aligning the workpiece with the machine and then establishing my XYZ coordinates using a probing sequence like I showed you in an earlier scene. With the jig mounted to the table, I can now begin carving. This first carve was meant to be a perimeter carve to the neck, but I had to abort it halfway through because the bit got bound up in the workpiece. Luckily, my machine has motors that stop the carving operation when something goes wrong. At this point, I decided to skip the perimeter carve altogether because it wasn't really necessary and it failed. So I moved on to the rough carve, which you're seeing here. One of the tricky things about CNC is using CAM software. CAM stands for Computer Aided Manufacturing, and CAM software basically takes your 3D model, analyzes its shape, and then plots out a series of what they call tool paths. With most tool paths, you're at the mercy of the software and have to rely on it making the right decisions, which usually it does. But in some instances, you're left to wonder why it makes certain decisions versus others, which sometimes manifests itself in very loud and alarming screeching noises as the bit pushes through the wood. By contrast, other carving operations like the one you're seeing here are more straightforward and involve settings determined by the user rather than the CAM software. This is the so-called finishing carve, which again, as we saw with the headstock paddle, is designed to smooth out the final product by removing the small margin of wood left over from the rough carve. In this case, I've opted for a finishing tool path that's going to move the bit across the length of the neck in the direction of the y-axis, with the bit advancing in very small increments, all of which is determined by the user rather than by the software. Finally, we have the so-called waterline carve, which basically traces around the outline of the neck and cleans up any vertical surfaces. This carve is meant to produce results similar to the aborted perimeter carve I showed you earlier, and like the rough carve, it relies wholly on the CAM software for how its tool paths are executed. Now, the first thing you might notice is how the tool path is sticking to one part of the neck, the tip of the headstock. You would think, like with the perimeter carve, that the machine would move along the entire outline of the neck, stepping down another increment with each pass. But here again, we run into another CNC quirk that's directly attributable to using tabs. In this case, the tabs cause the CAM software to treat the headstock as a separate segment of the neck, rather than moving the bit consistently along the entire outline. The result, to be honest, seems a bit illogical and produced some artifacts that I later had to sand out. Okay, now that all the carving operations are complete, it's time for the moment of truth. I need to separate the workpiece from the jig and then liberate the final product from the blank. To do that, I'll first loosen the side clamps, which at this stage are mainly holding the remainder of the blank to the jig. Then I'm going to unscrew the jig itself from the work table, which I need to do in order to have access to the screws that are holding the final product in place from below. Now that the jig is free of the work table, I can flip it over and from the back, remove the 3 screws from the threaded inserts that I installed in an earlier scene. With the workpiece now liberated from the jig, it's time to liberate the final product from the remainder of the blank. First, though, I have to remove the threaded inserts, which have served their purpose really well, I would argue, but they're no longer necessary so they can come out. Once that's done, all that remains is to cut through the 4 tabs, 2 in the neck heel and 2 in the headstock. To do that, I'm using a multi-tool and giving myself plenty of margin, because I'll have to file off the remainder of the tabs by hand anyway. All that's left now is to have a look and hope for the best. Okay, so there you have it, the process for carving a neck shaft from start to finish. As you can see, I'm holding that neck shaft in my lap, and I do believe this is going to be the final neck shaft for this bass project. You'll also notice that I've already installed the fretboard. Now the fretboard is going to be the subject of my next video, and I've got a lot of interesting things to talk about with respect to this fretboard, not least of which is my new strategy. It's an experiment for when I apply the finish versus when I do the other operations. In this case, I applied the finish before carving the fret slots, and that also means, of course, before installing the frets, which is unusual. Usually people do all that stuff first and then they put on the finish. Now I have reasons for doing that, but I won't give them away here. I'll just tease it for the next video and I'll explain them in the next video. But I have high hopes for this process and I think it's going to work. But in the meantime, I've got a really solid neck here and I'm pretty pleased with it. The thing that really came out nicely is something I've been worried about and have discussed in other videos, which is the seam between the maple fretboard and the maple neck shaft. Now this is the first time I've attempted this combination. And no, it's not the first time actually. I've shown you the first time, and that resulted in a really raggedy, kind of unprofessional looking seam, which really bugged me. So I set that whole neck aside, even though it was otherwise a pretty good neck, and I've carved this one now. And this one I kind of, you know, made up for some of the flaws in the first version, and it's looking really good. It's looking really kind of smooth. I love the fact that I fixed kind of the profile issue that I mentioned in the last video or one of my previous videos. So I'm optimistic about this. I think it's going to be pretty nice. But the next step, of course, is to install the frets. I've got a lot of finish sanding to do. That's for a future video. In the next video, you can look forward to seeing me take the fretboard blank, go through all the operations to include mating the fretboard, gluing it to the neck shaft, to do which I used a jig, a new jig that worked really well, and I'm really happy with the results I got, including the super tight seam. So that's what we'll talk about next time. Thanks for watching this one, and I look forward to seeing you again.